Hi, my name's Cheryl.
I'm Jerry.
Jamie.
Bobby.
Vanessa.
The ground starts to shake as an earthquake begins to rumble, frightening the citizens of this early civilization. The shaking is violent enough to cause clay pottery to fall from its perches, sending them crashing to the earthen floors. Mothers and fathers scramble on unsteady footing in a panic, attempting to protect their family from the wrath the gods have brought upon them. The rumbling in the earth grows louder, and the mountain looming over this primitive city grows angry. It begins to bellow dark ash, and the sky darkens. Lightning begins to flash within the darkness as the people attempt to flee the coming catastrophe. But the realization that they are too late only becomes apparent when the mountain explodes. More ash and debris shoots miles into the sky as liquid fire flows out of the wound in the earth, and the once thriving city of Pompeii, along with its inhabitants, are buried in the pyroclastic cloud produced by the eruption of Mount Vesuvius in 79 AD. Pliny the Younger, author of the only surviving eyewitness account, describes this tragedy as a sudden explosion followed by blankets of ash that fell on people as they tried to escape. The total of the casualties from this one event in time is unknown, but the archaeologists that have studied this area have unearthed and are aware of at least 1,000 victims that were claimed. Mount Vesuvius is one active volcano that rests on the Bay of Naples in southern Italy, and is one of many volcanoes in the world. Volcanoes are all over the world, some dormant, some thought to be dormant, and some quite active. Many people have heard of, seen, or experienced a volcano, but what are they really? Are they all dangerous? Are they all just ticking time bombs? And how can they be predicted? To answer these common questions, an individual must first understand what a volcano really is, and what geological occurrences might lead to the birth of one. To really understand what a volcano is, a person must first identify what volcanism is. And according to Britannica.com, volcanism is any of the various processes and phenomena associated with the superficial discharge of molten rock, pyroclastic fragments, or hot water and steam, including volcanoes, geysers, and fumaroles. Geothermal energy is a source of all this heat, but just because a place is heated from geothermal energy from the Earth's core does not mean that the birth of a new supervolcano is about to take place. In most instances, these hotspots around the globe are volcanic vents, geysers, and volcanoes that are constantly active. They constantly are relieving the accumulation of pressures within the Earth's crust and making it possible, the possibility of a dangerous explosion, pretty much very small. Places like the Old Faithful Geyser in Yellowstone Park and Mauna Loa, located in the Hawaiian Islands, are just two examples of areas that are constantly active. Mauna Loa is located on the Big Island of Hawaii. In addition to being one of the world's largest volcanoes, with a summit of nearly 13,700 feet, it is also one of the most active, and since 1843, Mauna Loa has erupted 33 times. Most recently in 1984, and at 60 miles long and 30 miles wide, Mauna Loa has a name that is fittingly means Long Mountain in Hawaiian. And it takes up about half of the Big Island of Hawaii, and its mass amounts to 85% of the other masses of the other Hawaiian Islands combined. Although volcanism is mostly associated with Earth, there are many signs that other planets within our solar system have also experienced these occurrences. The largest volcano in the solar system is actually located on Mars, and is aptly named Olympus Mons. According to geology.com, it stands about 25 kilometers, which is 15.5 miles higher than its surrounding landscape. And it is over 500 kilometers, which is 310 miles in width. Volcanic activity is in fact quite common, and the geothermal energy from around the world could actually provide a much-needed energy source to a world in need of new forms of energy. Around the world, forms of volcanism differ from region to region. And to better understand how they occur, an understanding of why, how, and where all of this superheated material comes into existence. All the molten rock or magma comes from the Earth's mantle and core. It receives its intense heat from the breakdown and decay of radioactive material that is located within the Earth. Even the magnetic poles of the Earth are caused by the eddy and flow of the Earth's liquid core. And due to the constant shift and flux of the Earth's of the core and the mantle, the crust is also constantly shifting. It's not solid as well, and it's actually formed by the many plates which move and shift with the constant flow and flux, and that pretty much gives rise to the theory of plate tectonics. As these plates bump into one another, a divergent and a convergent zone forms. From the convergent zone, which is the area where two plates are coming together, there forms a subduction zone. And the subduction zone is what happens when one plate starts to ride below another plate, forcing it to go deeper and deeper into the Earth. On the other end of this is the divergent zone, and that's where forces from the center of the Earth, the magma and mantle are forcing up on the divergent side of the plates. And that's where the plates are separating, and it's pushing up constantly, creating more crust as it forms and pushes apart. And on the other hand of this, with the subduction zone, that is where most of your explosive volcanic activity is going to happen. That's where the subduction zone is going down on a gradient, and it causes a plume of magma to start to rise up to their surface. And it creates a lot of pressure, and those forces is what cause an explosion or an explosive volcanic reaction in a lot of volcanoes, such as like Mount St. Helens. The power of such an eruption can be absolutely devastating, but thankfully the ability to predict such occurrences is possible. But unfortunately it's not accurate. And according to Time.com, Mount St. Helens was getting ready to burst for nearly 2 months before it exploded. Mount St. Helens has been dormant more than 120 years. And even though the eruption was anticipated, the manner in which it did erupt was not. At 8:32 a.m. on May 18, 1980, a 5.1 magnitude earthquake triggered a sideways blast that swept the mountain's north face away into a cascading landslide that shot a pyroclastic flow of hot ash and debris some 15 miles at speeds approximated at nearly 300 miles per hour. At the same time, a mushroom-shaped plume of ash shot 16 miles in the air, eventually covering 3 states. Complete darkness blanketed Spokane, Washington, a city about 250 miles northeast of the volcano. And when the ash came down, it fell in the form of black rain that literally coated the residents of Washington, Idaho, and parts of Montana with a fine gray powder. 57 people and thousands of animals were killed, and some 200 square miles of trees were obliterated. The prediction of volcanic eruptions is not exact science, but even though there are warning signs, the point to the possibility of an eruption occurring, determining exactly when and how is sporadic. And there are many methods for predicting eruptions, and unfortunately all these methods only point out to an area that is active. In conclusion, volcanoes are all over the world. Some are dormant and some are quite active. And to understand them all, you have to understand volcanism, which is any of the various processes associated with the superficial discharge of molten rock and pyroclastic fragments from the Earth's surface. Volcanoes can be devastating and dangerous, and the ability to somewhat understand them is possible thanks to some of these sciences like seismology and volcanology. And even though they're not exact science on prediction, having the ability to at least tell when an area becomes active saves more lives, especially when a volcanic blast can be as powerful as an atomic bomb. And I'd like to go ahead and open up the floor for questions and answers. Any questions?
I have a question. I don't know why. Anyway, my question is, during a volcano, does it always have lava spewing?
No, not all volcanoes form lava. Some of them might be just hot ash flows, maybe steam and water. Really, I mean, it differs from region to region. I mean, volcanic activity can be anything from hot springs, like a geyser like Old Faithful, to the Hawaiian Islands that you always see the pictures of with the gouting flows of lava and stuff like that. Or you might get just hot mud flows.
Thank you.
Anybody else?
I have another one.
Go ahead.
Do you always know ahead of time that a mountain is about to erupt?
Generally, from what U.S. geological surveys have said, there's usually some form of activity that preludes to the eruption that's about to happen. Usually it's something like there might be gaseous emissions, there could be trees and animal life dying because there's a lot of carbon dioxide maybe coming out of the soil and creating areas like that. The pH balance in nearby bodies of water might elevate to, not like, it's not like in the movies where it's like a lake of acid that's going to eat your skin, but the pH would definitely raise enough to cause alarm. Seismic activity, there's all sorts of different things that happen that lead up to an eruption, and it's not something that just instantly happens with no warning.
Thank you.
And I go ahead and close this out. Thank you.